Alright, so in our last video here for this introduction to polar coordinates, let's talk about graphing some equations. And let's start with something pretty straightforward. Graphing. Let's graph the equation r equals 3. How do we do this? Think back to what our polar graph paper looked like. Okay, remember here we have these circles would be like r equals 1, 2, 3, 4, and these lines theta equals 0, pi over 12, pi over 6, pi over 4, and so on. All right. So how do we graph this by hand? Well, this one you might have already guessed what it is. This says that no matter what theta is, r is always 3. So if we made like a chart of values, maybe I'll do it this way. R and actually theta is usually the input variable here, so we'll say theta and r. We did 0, pi over 6, pi over 4, pi over 3, pi over 2. No matter what we put in, that's always 3. So what does that mean? No matter the angle, we're always 3 units away from the origin. So, on the graph here, no matter the angle, we're always a distance of 3 away. So what we end up with is a circle of radius 3. It's a pretty bad circle, but yeah. So how does that make sense? Well, we know that we have an equation for r squared. So if r is 3, then r squared is 9. We know r squared is x squared plus y squared. And hey, look, that was an equation of radius 3, or an equation of a circle of radius 3, right? So it shouldn't be a big surprise. All right, let's look at another simple graph. What if I gave you something like theta equals pi over 6, let's say? What would this be? Well, here theta can't change, but r is allowed to change. So if we made another, graph or another chart here of values, we'd say like if r is 0, theta is pi over 6. R is 1, theta is pi over 6. R is 2, theta is pi over 6. If r is negative 1, theta is pi over 6, and so on. So what does that actually translate to? Well, what we do here is we say, all right, let's say this is the angle pi over 6. Looks close enough. We have to stay on this line that pi over 6 gives us, but r can be anything. Particular, so we can go as far out this way as we want, and we can go as far out that way as we want. And this is the equation, theta equals pi over 6. It's a line. Usually when we think of theta equals a value and we restrict to positive numbers, we only get sort of the array coming out of the origin. But if we allow negative r values, we can go the other way as well. So those are some basic ones. What are some more complicated ones? Right? Like the one we looked at the beginning. How do we get something like that? Well, before we go quite to that one, let's do one more example that's not too bad to do by hand. All right? Let's look at r equals 4 cosine theta. Right? So in looking at this one, let's make a value, a chart of values here. All right, so I'm going to go vertical this time. And let's look at our usual suspects. 0, pi over 6, pi over 4, pi over 3, pi over 2. And so if we look at these, and we plug all these in, plug in 0, we get 4. Plug in pi over 6, we get 2 root 3. Here we're going to get 2 root 2, 2, and here we get 0. Right. And then if we keep going to say 2 pi over 3, 3 pi over 4, 5 pi over 6, and then pi, right? We just see these go the other way. I think these are negative now, right? Because it's cosine? Yeah. Negative 2, negative 2 root 2, negative 2 root 3, 4. Right, and then, we can keep doing this over and over. But let's try and plot this as best we can. So let me try and draw some of these circles here. Try and at least try and give us some graph paper. All right, we're gonna pretend those are evenly spaced. And let's see, let's get these angles in. So here's pi over 4. The other common angles. All right, close enough. All right, so let's start plotting some stuff. So 0, 4 is out here, right? Or sorry, r is 4, theta is 0 is out there. When theta is pi over 6, r is 2 root 3, which is about 3.5. Let's say that's here. Right, 2 root 2 is about 2.8. When theta is pi over 3, we're exactly at 2. When theta is pi over 2, that's the y-axis here, we're at 0. Now, when theta is at 2 pi over 3, which is this line, the value is negative 2. So this is 2 pi over 3, but then we go backwards here. Right? And then likewise, for 3 pi over 4, we go to negative 2 root 2. 5 pi over 6 goes to negative 2 root 3, about here. And then pi, which would normally be over here, we go negative 4, and then we're back where we started. So if we trace this out, we end up with a very poorly drawn circle. And if you keep going past pi, you'll see that we're just going to keep wrapping round and round and round this circle. So we actually only need an interval from 0 to pi to graph this. Right? So let's see how this evolves, actually. I want to show you, if we're not doing this by hand, we can see this a bit nicer. So here is, zoom in on that a bit. So this is going to graph that equation for it. Again, as we increase from 0 to pi, we get the top half of the circle. And then once we go past the pi, now we close up. And then from pi to 2 pi, we can see we're retracing the top half of the circle. Right? And then we retrace the bottom half of the circle. Right? And there we go. Let's look at a couple more interesting graphs before we end for this video. Say something like r equals 2 sine of 3 theta. Think a little bit about what that might do. In fact, maybe even pause the video here and try and sketch it on your own. What happens here is this 3 makes a big deal here. This 2 is going to say, well, all right, it's going to go out as far as that second circle there in the graph paper. This 3 is going to cause something interesting to happen. If you think back to when you were learning to graph sine and cosine, numbers inside there affected the period of the graph. Right? When we put a number in here that's bigger than 1, it makes the period shorter. When we put something less than 1, it expands the period. So what happens to this? Well, it's now going to finish these loops much quicker, and so we see this. So this should be pi over 3 already. All right, there's 2 pi over 3. It finishes that second loop. And at pi, we finish up and close back up completely. Right? And then from pi to 4 pi over 3, we're just going to start retracing. Right? Well, from pi to 2 pi, really. We just keep retracing. And there we go. So we get this rose with 3 petals. Right? Again, the blue part is the graph. The purple circle here is just sort of showing us where theta is. Right? So again, just play that again. Right, so from 0 to pi, I'm going to trace this out. And then from pi to 2 pi, it's going to retrace that. Right, and that all has to do with the positive, negative values of r. Right? Now, to finish this off, I just want to show you a really interesting graph. Right? In the last example, I said, try pausing and then doing this by hand. Please don't on this one. I mean, you can if you want, but I wouldn't really recommend it. Right, so try and make a guess as to what the shape might be, though, for e to the sine theta minus 2 cosine 4. And see if you can guess what that might end up being. Right, and let's watch it draw up. And there we are. We got a nice butterfly out of that one. Good luck trying to get that in Cartesian coordinates. But yeah, so that's it for our intro to polar coordinates. Hope it was interesting and helpful. And yep, see you for the next one.